Hi, this is Abhishek and Praveen. We are going to talk about financial embeddings project. Word embeddings are representations of words in multidimensional semantic space as vectors. They are two words occurring in context, similar context with meanings, and two, there are two approaches to generate word embeddings: static and dynamic. Dynamic is also known as contextual. The static word embeddings are traditional vector representations where each word is mapped to a real valued vector. Some of the important word embeddings are word2vec, invented by Mikolov from Google in 2013, glove, and fast text. The next one is dynamic or contextual word embedding. When modeling polysemy words with multiple meanings, static word embeddings methods are suboptimal since they are only allowed to represent each word with a single word, whereas contextual word embeddings are derived with pre-trained language models, which were developed so that each word is assigned a representation that is a function of the entire input sentence. The main difference between the contextual and static embeddings is that the contextual embeddings provide not only the embeddings but also an entire model for the target task. The important dynamic word embeddings, some examples are Elmo, BERT, ExcelNet, Roberta, Electra, and we have experimented with these intrinsic tasks and extrinsic tasks for these word embeddings. Intrinsic tasks are for the uh, training, and the some important ones are the similarity, analogy, and odd one out task. Let's see what the similarity comes for the word loss. So we see that the first column, which is word2vec, Google News, the standard one, it doesn't give that good representations of loss. It has some words such as defeat and drubbing, which are not at all related to the loss in financial terms, whereas the one the word2vec which we trained on the data, it has correctly identified the loss synonyms as write-offs, write-downs, claims, adjusting, and realized, which are related to loss. Now, coming to the fast text, it does not do that well on either of the. Uh, एक second. प्रवीण जी, आप
हाँ
ना
हाँ।
म्यूट कर आपको वो ना ऐसे बहुत डिस्टरबेंस हो रहा है, मतलब जब आपकी बारी आए तब आप बोल लो, फिर म्यूट रहो। मेरी जब बारी आएगी फिर मैं म्यूट रहूंगा, ठीक है?
अच्छा, आवाज आ रही थी क्या कुछ मेरी साइड से?
और आपका फोन भी आ रहा था ना बीच में, तो आपको म्यूट कर लेना चाहिए अपने आप।
नहीं
ओके,
मेरा ठीक है।
ये पार्ट
वैसे
काट दूंगा मैं, बीच में पार्ट काट दूंगा मैं, दोबारा मैं बोलना स्टार्ट कर रहा हूँ, ठीक है? So the next words are seasonality. So we see that the Google trained one totally fails here. It doesn't identify anything good. But the one which we trained on financial embeddings, the 10 case, it finds interesting words such as cyclical and cyclicality. Interestingly, here fast text performed better than the previous cases. Now the next word is risk. We see similar things what we saw earlier with the first two words. Now talking about the analogies, which is the next intrinsic task, we see that the first analogy is that Apple has the operating system as iOS for phones. What about Google? The SEC trained word embeddings are easily able to find Android, whereas the Google News word2vec fails to find that. With fast text, the scenario is reversed. The wiki crawl one is able to find Android as the second best. Now the next two are again the similar type of analogies. Microsoft has Windows, Apple has Mac OS as products, and Microsoft CEO is Nadella, as Nadella is the surname. only the fast text was able to identify Sundar Pichai as the correct name here. Next, Foot Locker is a footwear company. Guess is a apparel company, and only the financial embedding trained word vectors are able to find that. Next task was odd one out, and the first set of these words, Guess, McDonald's, Starbucks, all of these are restaurants except the first one, Guess. Guess is an apparel company, and only the financial embeddings could find it. Then the next task was the first three items, inventory, receivables, payable, they are balance sheet items, whereas cash flows is related to cash flow sheets. So except the Google News, all others are able to find. The next one is kind of ambiguous, so let's skip it. So the results and discussion of this I have already discussed what we saw here earlier. Next, I'll pass on the presentation to my partner.
Next, let's look at the contextual embedding. Actually, this is in terms of BERT. It is also called as the language modeling. So language models are actually designed to ask targeted questions about linguistic capabilities. Okay, by examining word prediction in context. So they actually do well in terms of giving the word embedding as well as the sentence embedding. So we have trained the 10K corpus on the MLN model. Let's see some results in the next slide. So we have used the mask language model here. So if you can see the results, our model, which is the middle column. If you see, it actually predicts quite well in terms of the financial words, for example, exchange, statement, financial amendment. While if we compare it with the BERT base default model, it does well on the first case, but on the other cases, actually, it just predicts very general answers. So overall, the embedding looks good. Let's move on to the extrinsic task. So we have looked at regression classification and question and answering. So I'll be talking about regression and classification. So in regression, a problem statement is aspect-based sentiment score analysis. This data set is from FICA. It has, kind of very short sentences, and then there are some target and aspects which are already available for us to consider in our modeling, and we have to predict the sentiment score on a scale of -1 to 1. So if you look at the length of the words, it's between sort of 2.5 to 12, so very short sentences. Let's go to the next slide. So we have experimented with a couple of models, so it's kind of iteration. So we have finally arrived at a model where the sentence will go through the by LSTM, and the target as well as the aspect, the text goes through the LSTM, and then finally all three of them are concatenated and then passed on to the dense layer, which is a linear layer, to predict the scores. Let's go to the next. So here are the scores for the word to vector and fast text. So as you can tell that our 10K pre-trained model did reasonably well, but word to vect and fast text were actually better. In fact, the fast text, if you look at the out of vocabulary words, it has a capability of doing the character level sort of embedding, so it actually worked the best in this particular case. So here we could see that there is a sentence sales boost, so it appears to be a positive sentiment, and our 10K trained model actually predicts based on the context. I think it predicts reasonably well. And the last row, United financial irregularities, it looks negative sentiment related to the company reputation. And here also we can see that it has actually done well as compared to the default model. Let's go to the next. Okay, there's a delay in, yeah, okay. So now let's look at the contextual embedding from the BERT. So here what we have done is we have used the TABSA approach where we have created an auxiliary sentence, question type of a sentence by adding, prefixing a text like what do you think of aspect of target. So there are some research paper which have recommended, using these type of methods so that we can pass on the sentence pair in the BERT model and get better results. So let's go to the next slide. Yeah, so the BERT model, if you see the train model as well as the base model, both have actually done better than static embedding. Our language model has done slightly better, but it's not like having a large difference. Um, so at least we are confident that this TABSA approach has really worked well. Now let's jump into the classification. The classification, we have a corpus which is FinNum, which is full of tweets, and then there is a target column called relation. Here the length of the tweets are actually very large. It's about 30 or large or higher than that. So in terms of the model, when we use the static embeddings like word2vec and fast text, we actually build the LSTM model. It is a bi-LSTM model, which has a stack layer of bi-LSTM with dropouts before it goes to the sigmoid layer for classification. Let's go to the next. Yeah, so here for classification, I think we have got a better results in terms of our train model. So the results between the word2vec, our word2vec train model versus the fast text are really comparable. So overall, we see some good results from this. Go to the next. Yeah, so BERT, we have used the PyTorch, approach, which is suggested by Hugging Face, adaptation approach, fine-tuning approach, and we have got very good results as compared to the static embedding. Overall, the results between our train model versus the BERT base model, they still look quite close. We have also use the FinBERT model, which is trained on TRC2 data sets and benchmarked on FICA sentiment analysis, just to compare, how the results compare with the FinBERT. So we can see that even the FinBERT has not actually done very well on this specific corpus. So let's go to the next slide and look at how we could get better results. So when we started looking at the corpus, we see that the tweets has lots of a weird structure and the language and vocabulary, and it has lots of special characters also. So as compared to the 10K data, which is highly structured and like a standard financial document, this vocabulary is totally different. And I think this could be one of the reasons why our model has not performed better, as well as the FinBERT, which is already benchmarked on the financial data sets, is also not performing better. So overall, we feel that if we can, train our model not only the 10K, but also include some of the Google News, financial news, as well as some of the tweets, I think put together, then it could perform better. Next slide. I think handing over to Abhishek now on the Q&A.
So I'll talk about question answering. Consider this question of which a financial analyst would work on answering in their daily routine work. Why did Abbott's operating margin change in 2017? It involves these three steps, which an analyst will perform manually: finding the and opening the About's 2007 annual report, and then finding the passage relevant to operating margin, and then extracting the exact phrase, the reason for the margin fall. Creating an automated information retrieval and extraction system would involve the similar steps, but we need to automate them. So the first step is finding and opening the About's 2017 annual report. This can be done using named entity recognition. There are two named entities here, about the company and 2017, the date. And this involves another approach which can be done through Lucene, but that's not the focus of our project, so I'll skip this step. The second step is finding the passage relevant to the operating margin. It pertains to non-factoid question answering, which involves retrieving and selecting the most relevant sentence or passage level text as the answer for the given question. Selection criteria could be DF, IDF, or cosine distance from question, etc. Defining non-factoid, it means kind of like given these are the paragraphs which you find which one is the most relevant, which one might contain your answer to the question given. And to extract the exact phrase described as the reason is step 3. It's also called extractive question answering and or the reading comprehension. When an extractive question answering system is presented with a question and a context, it finds out the exact span. For example, the underlined words in this paragraph is the answer which is required. The end-to-end pipeline looks like this. You send the question on the left to the Lucene system. It finds the top 50 candidate answers in paragraph forms, and our answer re-ranker which has been fine-tuned, pre-trained on BERT, fine-tuned on SEC data, and then fine-tuned on FICA dataset, will find out the exact answer by re-ranking the answers given by the Lucene inverted index based information retrieval. This is so I'll move to the talk about the second step, non-factoid question answering. Here we demonstrated through FICA dataset, which is financial question answering dataset. It has opinionated questions and answers crawled from community websites such as Stack Exchange on investment topics. And we try the answer retriever, which returns a list of potentially relevant candidate answers using BM25. And this BM25 is based on TF-IDF, which serves as the baseline system for our comparisons, and then the answer re-ranker, which I talked about previously. Then this is how the QA model looks like. It's the basic thing is about binary classification, and then softmax on top of that to give a probability to each of the candidate answers. And these answers are then sorted in descending order to get the most relevant answers. What we input to the fine-tuning the BERT base is token embeddings, segment embeddings, attention mask, and binary labels. But the important change here compared to what we did, compared to authors of FinBERT QA, was that we used a length of just 128 spans versus 512 used by the authors. The loss function is based on cross entropy loss for better computational efficiency, and we have used Adam optimizer. These are the results. There are three important metrics to evaluate the results, and on all three of them, of course, the FinBERT QA, which was trained on 512 span, in the first column, as described by authors, gets the best accuracy. Our experiment with 128 span was just behind it with accuracy like 3% below that, but it still beats the BERT based, which is not using financial data pre-training or the BM25. And the step 3 was extractive QA, but it involves we tried creating a data set of 100 questions, but it was not enough. And moreover, the squad trained model was not that bad. there was scope for improvement, and it would require creating expensive training data set. Rather, it makes more sense to try BERT large or XLNet, which are better at getting longer sentences. So for scope of future improvement, I would say that we can do data munging, extract the relevant sections from the 10Ks, and we can use the knowledge graph specifically for financial industry, and we can extract the tables and create sentences from them using regular expressions. We can use metadata, time tags, and the better models, which I talked about in last slide. Yeah, so that's it pretty much from our side. Thank you very much for listening.